This video is not meant to be a depressing video or killing your vibes because it is labeled as EEG of death or AKA brainwaves. It's purely scientific because there was a document that came to my attention, or article, I should say, where there were some neurologists who had were able to gather, collect, and observe a patient's brainwaves data, EEG data, while this person died. And this was, if I'm not mistaken, it was an accident because obviously we don't have any previous research on looking at what happens in the brain when people die. So this, on humans at least, we have it on rodent, but not on humans. And so this particular situation, although I don't know the details, it was sort of something that happened. They were already collecting this patient's EEG, and this patient happened to die during that time. And again, this is nothing about like religious, spiritual, anything like that. This is pure scientific and looking at this data that they collected. Very, very interesting is that I'll show you the paper more in a moment, but before looking at that, one of the things that they saw was there were increased amount of gamma waves, gamma bands in the patient, even after the cardiac arrest, right after the death. And I think there were several seconds that this happened. And gamma waves, gamma bands, if you're not familiar with it already, is one of the highest frequency that the brain emanates. And it starts from around 30 hertz up all the way up to 100 hertz. And one of the main reasons that, or times that we have been able to detect that when a human emanates gamma waves is when the person is extremely focused and it's at their highest peak of performance, specifically cognitively. Some people also say that it happens because they are maybe more in a very alert, highly alert, cognitive alert state. Some people say that it also is when people are more creative. However, different scholars define gamma waves. One thing that they all are consensus about is the fact that gamma bands are observed in human brain mostly when the person is on an extremely high alert. Now, we can interpret that in different ways. That's really, really up to you and everybody else who reads the paper. But nonetheless, this is what they, excuse me, what they were able to detect. So I'm going to share my screen with you here, and we can look at this together. So this is basically the paper, and I'll put the link down below as always. But very quickly, I wanted to read about, oh, by the way, before doing that, I wanted to show you that if you are not familiar with gamma waves, this is potentially how a gamma wave looks like. Essentially, it's around 30 to 100 hertz. And as you can see, the frequencies are much higher. If you compare it, for example, with delta is, or even theta, they're very, very lower frequencies. And this is like much, much higher. And so here is this paper, and this is what they are talking about, that essentially they were able to, by accident, collect EEG data of a person who went into cardiac arrest. And one of the things that they're saying is that after cardiac arrest, most of the bands, delta, beta, alpha, they decreased, but a higher percentage of gamma power was observed. So in other words, while the other bands decreased, gamma bands first decreased, but then it increased. And once you read the paper, you'll get more information about the details of this in terms of how that happened, when that happened, etc. But just for the sake of not having too long of a video, I want to show you the conclusion, the discussion, excuse me. First paragraph here, where they're actually talking about what we just talked about. So basically, the gamma power after a suppression actually decreased. So first there was a decrease, and then there was a increase in it. And then they also look at the cross-frequency coupling that was looked at, and it was gamma as well as alpha bands in there. And they also looked at interregional coherence analysis. And all this they looked at before cardiac arrest, during and after the cardiac arrest. And these findings suggest that that an intricate interplay between low and high frequency band take place after gradual cessation of cerebral activity and last into the period when cerebral blood flow is ceased, which means the post-cardiac arrest, because even during the cardiac arrest, there is still blood flow into the brain, but post-cardiac arrest, then there's still some time during the cardiac arrest, but post-cardiac arrest, there are times that this sort of ceases, the blood ceases to flow into the brain. And it's very interesting that this brain waves were even observed post-cardiac arrest. So it's very, very interesting. I highly recommend you read it, because then they tie it back into what this could potentially mean. Obviously, we can philosophize about it and come up with a bunch of unfound discussions about what this means, but purely scientific in terms of just observation of that. This paper is amazing in that it's the only time in the history of humanity that we actually have data about this, because this happened during the person's death. Because for obvious reason, ethics reason, we cannot do this with dying patients. So it's one of those rare times that this sort of happened. But purely at a scientific level, you can, talk about, for example, what this potentially means. They also talk about the time where the brain is deprived of oxygen and what happens, etc. And they also make the connection between what they found in this article with the times where the same EEG was collected from rodent in a highly controlled labs, because we have that, for example, with rodent in this case. There are a lot of labs that do a lot of different experiments on rodents. I was never one of them. I don't have the guts for it, but this is the case. So anyways, this was very interesting. And at some point they talked a little bit about also what this, but again, what this potentially means, but this is the article that made it very scientific. I saw that there were other articles I saw that there were other articles that had cited this article, but then they took it to the next level in terms of philosophizing about what this potentially mean. But again, these scientists did not do that. At least I don't think they did that. They were just talking about it from a pure scientific point, pure observational, data observational. And the fact that they were able to draw the similarity between that and the ones that we have on rodent, it's very, very interesting too. That just goes to show that it's all like at a very, very physical level. And but again, just looking at it from this point, it's very interesting. Again, other articles came out and wrote things about it, but then they took it to the level of having discussions about what this means. But I leave those philosophical thoughts and discussions up to you. For me at this point, this was just a very interesting paper that I wanted to share with you. All right, guys, I hope you're doing well. By the way, anybody who's interested in Neuromatch Academy, the funding is available for one female or maybe two females, depending on the applicants. Once you come into the Neuromatch Academy, if you're not accepted to Neuromatch Academy, obviously this funding would not be applicable to you to apply. But once you know that you got in and you have the paper to show it, feel free to apply to the funding that I'm making available. Thanks for watching. See you guys next time. Bye.